Good day, students. This clip we're going to be doing a pre-quiz review on complex numbers. So write down the title for this lesson. Pre-quiz review. Pre-quiz review on complex numbers. Alright, so let's write down the learning objective for today. And we'll go ahead and take a look at some examples. Alright, so learning objective. Learning objective. The learning objective is as follows. By scoring 80% or higher on the quiz, by scoring 80% or higher on the quiz, you will apply the Moivre's theorem. The Moivre's theorem along with the product and quotient properties in evaluating complex numbers. Okay, so that's the learning objective today. The goal is you have to score at least 80% or higher on the quiz. If you can accomplish this, then you have met the learning objective for this pre-quiz review. Alright? Alright, so let's take a look at some examples. We're going to be doing a product, quotient, and power and principal roots of complex numbers. So example 1, we're going to be a two-part example. If z1 equals 2/3 over 3 cosine pi over 3 plus I sine pi over 3, and z2 equals 3 over 5 cosine pi plus I sine pi, find the equivalent forms of the following. And find the equivalent forms of the A part will be z1 times z2, and then the B part will be z1, or let's say z1 over z2. Okay, so let's do the A part first. To do the A part, or A, we're going to apply the product formula. So the product formula just simply means you multiply the radii or the absolute value and you add the angles. So the formula is r1 r2 times cosine theta 1 plus theta 2 plus I sine the same as theta 1 plus theta 2. Alright, so add the angles, multiply the radius or the absolute value. Okay, so let's apply that to this problem. So this is r1, r2, we're going to multiply them. We're going to have 2 root 3 over 3 times 3 over 5, and that will take cosine of pi over 3 plus pi. How about we convert these to degrees so it's much easier? We know pi over 3 is 60 degrees, because pi is 180, 180 over 3 is 60, and pi is just 180. So how about we just use 60 and 180? It's easier to add those. So it's going to be cosine 60 plus 180, that's theta 1, that's theta 2, plus I sine 60 plus 180, like that. Okay? Alright, for the quiz, I'd like you to express the answer in both rectangle and polar forms, alright? So just keep that in mind. Okay, so let's work this out. So if we multiply these two, we're going to get the 3's cancel out. So we're going to have 2 root 3 over 5 cosine 60 plus 180 is 240 plus I sine 240 degrees. Now this is your answer in polar form. Alright, and we're going to express our answer in rectangular form in a minute. Okay, so there you have it. Okay, now we need to express our answer in rectangular form. So let's see. I need the cosine and sine of 240 degrees. Is it on a unit circle? If not, we have to use a calculator. So let's look at our unit circle real quick. There goes our unit circle. 240 is right here. So negative 1/2 and negative root 3 over 2. That's what we're going to use. It's on the unit circle. So 240 is negative 1/2 and negative root 3 over 2. This is the cosine, and that's the sine. So we're going to put them in, alright? So we're going to have 2 root 3 over 5 times negative 1/2 minus root 3 over 2i. We just distribute this number to both of them, and that will give us the final answer. So when we do the distribution, we're going to have 2 root 3 over 10. Negative 2 root 3 over 10 minus 2 times root 3 times root 3 is root 9, which is just 3 over 10. Okay? Negative 2 root 3 over 10 minus 2 times 3 over 10. And we'll simplify this. We're going to have negative root 3 over 5 minus 3 over 5i. Alright, let's put an I over here too. Alright, so there goes your answer in rectangular form. Alright, now let's move on to take a look at the B part. The B part, we're asked to find Z1 over Z2. Okay, so let's look for what that is. I'm going to go ahead and delete these problems so I can make room for the next one. So what do we do when we are asked to divide? When we're asked to divide, the formula for division is like the opposite of the multiplication formula, right? So if you're asked to divide or take a quotient, what you do is you divide the absolute value of the radius, and then you do the difference of the angles, theta 1 minus theta 2, plus I sine theta 1 minus theta 2. Okay, just like the inverse opposite of what we did before. Alright, so let's apply that over here. So we're going to have R1 over R2, which is 2 root 3 over 3 over 3 over 5. Doesn't look too good. Times cosine. 60 minus 180 will give us negative 120. Plus I sine negative 120. Okay? So let's simplify this fraction right here. If you have a fraction over a fraction, you multiply by the reciprocal of the denominator, or you DCF the problem, right? You drop the top, change the division to a times, and you multiply by the reciprocal, or you flip the bottom, 5 over 3. Multiply that out to get 10 root 3 over 9. Alright, so there goes the quotient of these two absolute values in radii. Okay, so we're going to have 10 root 3 over 9 cosine negative 120 plus I sine negative 120. This gives us the answer in polar form. Okay, so there goes your answer in polar form. Now, of course, we have to express it in rectangular form. So to express this in rectangular form, we need to find negative 120 on our unit circle, find the respective coordinate values, and then use it to determine our sine and cosine. Okay? So, negative 120 should be on our unit circle, right? If I know 120, then I can reflect to find negative 120. So 120 is right there. So if I want to find negative 120, it's just like a straight down reflection right there. Boom. Like that. See that? Straight down reflection to this point, which is same as 240. So negative 120 is negative 1 half negative 3 over 2. Okay? So negative 1 half negative 3 over 2. Negative 3 over 2. Remember, the x coordinate is the cosine, the y coordinate is the sine. So put that here. We're gonna have 10 root 3 over 9 times negative 1 half minus root 3 over 2i, and then distribute that. That will give us negative 10 root 3 over 18 minus 10 root 3 times root 3 is root 9, which is just 3, right? Over 18. Alright. Now to simplify that, we're going to get negative 5 root 3 over 9 for the real part, and for the imaginary part minus 5 times 3 is 15, right? So minus 15i over 9. Okay? Now, why did I do 5 times 3? Because 2 goes here 5, and 2 goes here 9 times, right? So we're going to do 5 times 3, 15, and then we're left with 9 on the bottom. So there goes your answer in rectangular form. Alright? Okay. Now, let's take a look at power. It's polar and it's rectangular. Example number 2. Example 2 is as follows. Example 2. Find 1 half minus root 3 over 2i to the 4th. Okay? So to do this one, in order for us to apply the Morris theorem, we need to express this in rectangular form. I mean in polar form first, because the Morris theorem says that you raise the absolute value to the power times cosine of n times the power plus I sine n times the angle. Sorry. Alright, you distribute the power to the angles, and you raise the absolute value to that power. So this is what the Morris theorem says. So it is in polar form, so we have to express this in polar form first. So polar form, we need r and theta. R is going to be the square root of a squared plus b squared, usually Pythagorean. So it's going to be 1 half square. Write that properly. The square root of 1 half square plus negative root 3 over 2 square. Alright? And that gives us the square root of 1/4 plus 3/4. Then when we add them together, we're going to have the square root of 4 over 4, which is the square root of 1, which is just 1. Alright? Theta is going to be the inverse tan of b over a or y over x. So inverse tan of negative root 3 over 2 divided by 1 half. I don't want to divide by a fraction because it's going to look messy. Why don't I just drop change and flip this? 2 over 1. Multiply by the reciprocal. Okay? So this divided by that is the same thing as this times the reciprocal of that. So these two 2's, this and this cancel out. And then we're going to have the inverse tangent of negative root 3. Alright? So what is the inverse tangent of negative root 3? You can take a look at it in your calculator. Or you can also use your unit circle. If you have a unit circle, let me see, tan, well, it has positive root 3, it doesn't have negative root 3. So let's just use a calculator. So I want my answer in degrees, so let me make sure this is in degrees. Always resets itself to radian every time I turn it up. So inverse tangent of negative root 3 is negative 60 degrees. So there goes theta. Theta is negative 60 degrees. Alright? So we're going to apply, let's rewrite this question in polar form first. So 1 half minus root 3 over 2I to the fourth can be written as 1 times cosine negative 60 plus I sine negative 60 raised to the fourth power. Alright? So now we're going to apply the Moivre's theorem, and it's going to become 1 to the fourth cosine 4 times negative 60 plus I sine 4 times negative 60. Okay? So there you have it. And then we'll simplify it. It gives us the polar form. So this becomes 1 times cosine negative 240 plus I sine negative 240. Okay? And then to finish this out, we just, okay, this is the answer in polar form. And in rectangular form, we look for negative 240 on the unit circle, and then we'll finish this up. So where is negative 240? If 240 is right here, negative 240 is going to be up there, negative 1 half n root 3 over 2. So 240 is negative 1 half n root 3 over 2. X coordinate is a cosine, y coordinate is a sine. So let's input that here. Is going to be 1, doesn't even do anything. Let me just put it there for fun. 1 times negative 1 half plus root 3 over 2I. We just distribute the 1, our answer doesn't change. And the interior part is just negative 1 half plus root 3 over 2I. End of story. Okay? Alright. This were fractional exponents. All you do is just distribute the fraction here and distribute the fraction here. Alright? Okay.